All right, so it is Tuesday, March 14th at 7 p.m. Eastern Time, 4 p.m. Pacific Time, and we are now in week number 6. Kind of hard to believe that 5 weeks have already gone by in the course, yet here we are. All right, so as we do every week, we're going to start out by taking a look real quickly here at our syllabus. And there's a couple key things to take note of here. All right, so March 13th, that was yesterday. So here were the two activities we had to do yesterday. We had the Module 4 discussion about Git, libraries, JSON, XML, YAML, and more. And then we had a single activity, which was Lab 4.9.2. And so Lab 492 was a pretty big lab, which is why you guys had all week in order to get that done. And we'll talk about Lab 492 in a second here. Now, this week, which is the week that will end on March 20th. So week 6 ends at 11:59 p.m. on March 20th. And again, you've got two activities. We've got the Module 4 exam, and then you've got project activity number 3. And so project activity number 3, I had alluded to a few weeks ago. And so let's pull up 494 here, 494. And so I would highly recommend that you take some serious time to read through, and hold on one second here, it does this. There we go, I want to get there. All right, so for section 494, I highly recommend that you take some serious time and read through the project activity 3, social coding, and what it is you guys will be doing. And up until this point, if I'm not mistaken, I believe both groups have selected option number 1, which is to enhance the already existing MapQuest API Python application that you guys created just this past week, right? So your manager has requested that you do some new stuff and that you add some new bells and whistles. And then you've got your project workload and status, team roles. Now, this is going to be the challenging part here, is that probably your Scrum leader, whoever that is going to set up a GitHub repo so that everybody can collaborate with what's going on in terms of the code that you guys are working on. And so each person should have something to do in the file. Again, there's no way for me to check, but I think you're doing yourself a disservice if you kind of sort of opt out and allow the rest of the team to carry you. But everybody should have something to do in the project file. And then you guys are going to do your application development, and then you guys will have a final presentation. So when will the presentation take place? So this is going to be important. And I think this is the good news for tonight. So you'll notice, and like I said, I wish I could say that I did this intentionally, but I didn't. But you're still going to benefit from it. You guys are still going to be really, really happy about this. So this activity here that shows, this is the 494 project group activity that shows that it is due this coming Monday, is not going to be due this coming Monday. I am going to push it out so that it's not due until the 27th. Or I'm sorry, I'm actually going to give it its own little special thing here. I got to make sure I keep my dates straight. So because you'll probably notice that next week, which is the week of the 21st, right, we have some activities that we'll be doing, right, or activities that are ultimately going to be assigned, even though we are not meeting, right? So, and these activities are, and I've kind of always been curious as to why they put them in module 5 and why they made this whole module. And it's really sort of like networking 101 review. And so these 3 packet tracer activities are extremely simple activities. I mean, you just sort of follow along with what the instructions are, and then you're done with the activity. There's a lab where they show you how to use ping and traceroute. So this module, I've always thought if they were going to put it in here, it should have been at the very beginning of the course, not here in the, right in the middle of the course, because it kind of really breaks the rhythm of what we're doing when we go from, doing a bunch of REST API work and creating Python scripts and doing some cool stuff with MapQuest to dropping back to sort of this basic networking 101 material. And then then you hit terminal velocity again, and we go into building a sample web app in a Docker container. So this was originally going to be due this coming Monday, right? So Monday the 20th, but we're not meeting. So I'm going to push that out. Again, we're not meeting the week of the 20th. So I'm going to push it out actually so that it's due this week here. I'm going to put it on the 27th. So you guys are going to have all of this week to work on it. You'll have all of next week to work on it. And then it would be due on Monday, March 27th. So that's going to give you guys a couple of weeks to work on that activity as a group. And hopefully that'll give you some extra time. Again, these activities here, I mean, you're probably looking at this going, oh my God, 3 packet tracer activities. These are super simple activities. And the lab is super simple as well. And then you've got the Module 5 exam. So this will be due Monday, March 27th. In fact, let me flip this here right now real quickly. Let's edit this. And we'll put this on Monday, March 27th to give you guys an extra week to work on it. There we go. And so if we go back to our syllabus, we should see, and hopefully the oops is not a bad thing there. Yeah. All right. So really the only thing you've got this week is the Module 4 exam, right? And then the following week, you've got these activities here. Again, very simple activities, but please do not wait until the last minute to start 494. Hopefully your groups are ready to go and you guys have kind of figured out what it is you're going to do and what are the features you're going to add. And you saw some of the features you could add last week when we met. So again, there is no class meeting next week, the week of the 20th, right? And so the only thing you've got due is the Module 4 exam, Monday, March 20th. And then you should start working on the packet tracers here for the basic network stuff. And then again, like I said, we go into Module 6. So any questions? We got spring break next week, so no meeting Tuesday night. And you got an extra week for your project activity, social coding. So the only thing you've got this week is the Module 4 exam, 10 attempts, 5 hours per attempt. So take advantage of them. So any questions there? No questions? Everybody's good? Okay.
I'm good.
Okay. All right. So if you guys are good on that, let's go ahead and transition to, and I'm going to flip over here to the virtual machine. Can you guys see that okay? I'm on the Dev ASC virtual machine right there. Do you see that?
Yes.
Okay, good. All right. So we're going to talk about some of the MapQuest work we did. And the reason I'm asking you if you can see this is because that is actually what you're looking at right now is my iMac that is in Maryland, and I'm actually remote desktoped onto it right now. So, because I keep the Dev ASC virtual machine running there all the time. Okay, so when we looked at the MapQuest work that we did last week, what questions do you have on the MapQuest application that we created? Other than, so remember that the fuel used is no longer supported with MapQuest. And they actually updated their documentation. So that was no longer included. And so they went ahead and they discontinued support for that feature for whatever reason. They're just not supporting it. So what questions do you guys have on the MapQuest? And let me go ahead and say, I think this is oh no, that was and then what did I do? 7, I think is what it was. Yeah.
Um,
So, oh, go ahead.
could you bring up the code on your screen?
Yeah. Do you see it right here?
Yeah, yeah.
Okay.
There, trying to think. There was something. Let's see. Um, what what was the? Actually, can you scroll down a little bit, please?
Yep. Any part in particular?
There was. I'm trying to think. Yeah, then okay, yeah, I remember now. It was the last part where the errors are.
Ah, yes.
So status code. Um,
Let me scroll up a little bit here for you. So the status code, you're talking about the JSON status.
yes.
Yep.
So let me see. Let's see. I'm trying to remember what there was something I was.
Was it where that value comes from?
Yeah, the status code. Was that defined? That wasn't a variable, was it?
So we
Like
created a
JSON
variable.
status or JSON data?
Yeah. So we create a variable name, and I just called mine JSON status.
Okay.
And this is basically checking to see if the status was 0, then we would do this here. We would print API status. We would convert the status value because that's going to be an integer. So we convert it to a string so that we can append it to this string here. And there's a couple of ways that you could have done this. They chose to show you how to do appending things. And so what they do here is, remember this value, because there's no quotes around that. So that's an integer. And in fact, let me give you a really good example. So I'm going to pop back out here into, so this is my laptop here, right? So if I was to say Python 3, right, and you can see I'm in the interactive interpreter. In fact, I just upgraded my version of Python the other day. So if I did the following, Dwayne, if I said, num1 is a variable name, and I'm going to assign it the value of 99. And then if I wanted to do a print statement of some kind, I could say print, we'll say the value of num1 is, now, if I do the following and I put the plus sign here and I say num1, right, we would think that what that's going to print out is it's going to say the value of num1 is 99. The problem, and this is one of the little semantics with the printing when you're working with strings, is that the plus sign is trying to concatenate these two data types together. So when you've got a string and an integer, Python says, hey, you can't do that, right? And you can see here we get this type error that says can only concatenate a string, right? Not an integer to a string. And so what it's telling you is you can't concatenate an integer and a string. Now, I could do something like, I could say num1 plus 1, right? And that'll work because that's not concatenation, that's addition. And so this is one of the things with Python that can be a little bit confusing for learners who may have had some C programming experience or some Java, where the data typing, it's referred to as strong data typing, where you're having to declare, hey, variable X is an integer. And if you don't declare that in C and in Python, then the program doesn't even run. In C, it wouldn't compile. And in Python, you're going to run into issues, or I'm sorry, and in Java, you'd run into issues where the Java virtual machine is going to choke, right? So Python just kind of looks at things and it uses loose typing, right? So it just kind of looks at what you type, and based off of what you have there, it kind of makes its best guess, like, okay, well, if he's got two integers there and the plus sign is between them, well, he must want to do addition. But if I've got a string and what would be considered an integer here, then Python looks at that and says, oh, well, the string and the plus sign, he's trying to concatenate two strings together, right? Like, two sentences maybe as an example. And Python says, no, 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 you can't do that. You can't concatenate a string and an integer. So here's how Python is going to handle that. They're going to do what's called typecasting, right? And the best analogy I can give you for typecasting is like if you're cast for a role in a movie, right? Like you're Dwayne and you're cast to play, Rambo, let's say. So you're going to go pretend to be Rambo. And it's kind of the same thing here. Num1 is Dwayne, right? But we need Dwayne to be a string. So we're going to cast Dwayne's role here in this Python statement as a string. And so for just this statement right here that we're trying to print out, we're going to have that integer, num1, pretend that it's a string, and then it would work. And so on a larger scale, that's what's happening back over here. Again, in a sort of a much more complex example, over here, that's what they're showing you. Now, again, there were a number of ways that this could have been handled, right?
So real quick, so by putting
Go
the string in front, you're telling it to read that value.
This right here?
Yes.
Yeah, so basically we're using the string function, right? Because that str is a function here. And what that function does is it takes an argument, and the argument is JSON status. And what it does is it converts whatever you put in there into a string. So JSON status, which we captured in the variable name JSON status up above, is an integer. And we know it's an integer because if you remember where that comes from, it comes from the JSON data itself, right? So at the very, very bottom of the JSON data that MapQuest generates, it gives us the status code. And so are we good to that point? Is everything I've explained kind of making sense right now?
Yes.
Okay. All right. So let's do this. Let's run one of the earlier incantations here and I have no idea which one of these is going to be. Yeah, okay. Yeah, so here we go right here. Perfect. I got lucky, I picked the right one. So here is where we create the variable JSON status. Now remember, it's just an object, right? It just holds a value, and the value that it's getting assigned is we're going to look at all of that JSON data that got dumped out. We're going to parse down to the info key, which gives us a dictionary, and then we're going to say status code. We're going to provide the status code key for that dictionary. And the status code should be 0 if everything works. So let's run this to see where in fact is this, we look at the JSON data, where is info, the key info, and then the key status code? How do we get there? And I know that this can be probably the most confusing piece of what we're doing is the parsing of this JSON data. So let's say *3*, and that should run it. Oh, okay. So we'll say, well, here we go. We'll say South Lake Tahoe. And if I wanted to drive to Crofton, Maryland tonight, let's see what we're looking at here. All right. So we see all kinds of information, and you can see here that what we got back was 0. What we wanted it to print, hold on, let me see if one of these prints out. I didn't even look at that. Oh, hold on. I want to quit. What are we doing here? There we go. Okay. So I wanted to see the one that actually prints out, and this is probably not the one. let's see if it was 2. And it would be easy enough to fix this up here. Print this one. Okay, here, well, let's just do this. Let me pull up 3 again. And we're just going to come down here to the bottom. Wait, was that 3? That was not 3. So we'll do 2. Because I'm trying to get one that is not going to put a ton of stuff on the screen. Okay, so we're going to uncomment out this JSON data one right here. So that's going to print the JSON data. And so we're going to see the JSON data when we run Python 3 *2 *. Oh, route error code. Okay, so something was wrong with the route. And let's go check and see what was wrong with our route up here. Oh, we left the origin blank. Okay, this was one we were messing around with to get a different HTTP status code, I believe. And so let's put in here origin. We'll just put South Lake Tahoe, California. There we go. All right, so now we should see a whole bunch of JSON data here. So let's do that right there. All right, and here is all this JSON data. Now, toward the end of this JSON data, you can see that we have this key here, this info key, and then you've got the key info, right, has a value, and the value of that key is this dictionary. And in this dictionary is where you find status code. So that's why we have open bracket info, and that gets me the dictionary, and then I have open brackets status code. So I want the value for info, which is this dictionary here that goes all the way to, looks like down to here, right? So if I say JSON data, right? Well, that's that statement we have. It says JSON data, and then it's the open bracket, and then inside quotes info, and that's the key here. And then I get the value, which is this dictionary. Well, if I want to get the value for the status code, I just need to give the key, which is status code. So I say brackets info brackets, and then brackets status code brackets, right? And that's what we see, and that's how we get that value. Now, remember that there's a much easier way, because this is kind of hard to look at, right? And this is where, hold on one second, we've got somebody typing in. And so this is where, if you remember from last week, we talked about the JSON view, and this is what I'm looking for here. So up here, I printed out the actual URL. So I could copy this, because this will be much easier to read. And if I pull up my Chromium browser and I type in, or I'm sorry, I paste in that URI, which is our RESTful API request that we are sending. It's a GET request, HTTP GET request that we are sending to MapQuest and the MapQuest API. And then it formats it. So if I go all the way to the bottom here, this is where we see that top level key info and then status code. And so that's why in the code, if we look at the code one more time here, and I say more *2*, at the very bottom, right, we create a variable name called JSON status. And what is the value going to be? It's going to be what we parse out of the JSON data that has the info key and then the status code key. And what you have, the value for status code, if we go back to the browser, you'll see it is 0 because it was success. And there it is right there. And so that's the value we're trying to get. But remember, that is not a string. That is an integer value. In fact, how could we prove that that's an integer value? Well, if I came back into this script here, all I would have to do is right under this, drop another print statement in here that says type JSON status. right? So I'm printing up. And so let me make sure, is everybody following me here? Does this line make sense, what I just added here? So I'm printing, and we're using that Python built-in function type, which does what? Tells you what data type a variable is. And in this case, we want to know what variable type is JSON status. And so that is all that would be required. And let me save this here. And then let's run it again. But wait, before we do that, let me comment out the printing of the JSON data, because then I don't have to page up like 100 lines. So we'll do that. Because we don't need to see the JSON data. We just need to see, we're interested now in, well, wait a minute, you're saying it's an integer. And there you go right there. And so that is an integer. So let's level set right here. So any questions on anything we've looked at right now? Does that make sense? Where I got that value from, how we got, and more importantly, how we're getting those values out of the JSON data. Is everybody everybody's comfortable with that? Okay, good. All right, good.
So how would you print what that value is? Like when you were back there, it said the status code was equal to 0 right now.
You're talking about right here?
No, back on the MapQuest page.
On the browser, in the browser?
Yes.
This
so right there, status code 0. Is that the value that in MapQuest right now that
yeah, so for
status code?
Exactly. And so what that represents, Dwayne, is this is basically MapQuest telling me, hey, your request succeeded here. Status code 0. And again, this is different. And this is where it gets a little bit complicated. Is that status code, that is MapQuest saying, hey, everything's cool here for the information you asked for, right? And if we did, and I guess let me take a step back. So the status code is MapQuest saying, hey, your request, we're good to go. Here's the JSON data, your route information, everything you gave me was great. This is not an HTTP status code, right? Because remember, with HTTP, we would see a 200 status code if everything was okay. So, and that's where this becomes a little bit confusing, is and again, this question came up last semester as well. Learners will see this and they say, well, wait a second. We read in the chapter that the status code should be 200 for an HTTP GET request that succeeded. And you're correct. It should be. This isn't an HTTP status code you're looking at. This is just simply MapQuest saying, hey, your request to me was legit. The data you had in here was legit, so we're good to go. And that's different than the HTTP status codes that you get. In fact, let me show you, right, how you can see that very easily here in this request. So where is so you see right here, we have on that line, let me highlight that for you, I apologize. So on this line right here, you can see this is where we're doing our requests.get. So this is where we're sending our HTTP GET request with the URL. And you can see that right below that, or before we do that, we're capturing that value, right, in this HTTP response variable. And now remember, this is an HTTP response is the name of the variable, and it's a response object. So it's an object in Python. And what do objects have? Well, objects have attributes, right? Just like when I kind of showed you, we create, remember, a class is an object factory. And if we had a class called cars, that class, we could generate a whole bunch of objects from that class, like car 1, car 2, car 3. And those cars could have attributes, which would be, is it a 4-cylinder? Is it a 6-cylinder? Is it a 12-cylinder? Is it an electric car, right? So, and those are considered attributes. Is it manual? Is it standard? right? Those are attributes that the car would have. And the same is true here. When we send the requests.get, right, the get request, we capture what comes back, which is a response object. In this HTTP response is the name of the variable. And so that object, HTTP response, has attributes. And one of those attributes is the HTTP status code. And to get that, just like you would with the cars that we created, when you said like car one dot engine, right? It would tell you 4-cylinder, 6-cylinder, whatever the case may be, or car one dot model, right? Is it or car one dot manufacturer? Is it a Ford? Is it a Ferrari? Is it a Lamborghini? Right? So we just say HTTP response dot status underscore code. And that value, which I'm going to print out right here. Whoops. What are we doing there? I'm going to print out right here. So I could say print HTTP response dot status underscore code. And so that'll actually print out the status code. And what this if statement does is it's checking right now. It's checking to see if the response, or I'm sorry, if the status code for the HTTP GET request is equal to 200, then we say, hey, the GET request worked. And then the else is, right? So if that's not true, what that means is the response code was not 200, then we've got problems. And so this else is going to raise an exception, and it's going to say, hey, we've got problems here. The status code was, and it's got this, and actually that would have to change there. So it's got this status code value. It's going to give you whatever the status code was that came back, right? If it wasn't a 200, it's going to show you, hey, you got like a 404 error, meaning resource isn't there, can't find it, right? But there is a typo here because it should not be R. It should be HTTP response because that's the object we're going to get the status code from. So let's run this and let's see. And it's going to show you the status code value. So let's go ahead and say Python 3. And we're not going to see all the JSON data. And you can see, you can see right here, 200. Because again, we didn't put any text in front of it. We just kind of printed it out. So that is the HTTP response code, not the MapQuest JSON response code. And you'll notice as we got deeper into the project, when we come down here, you can see that it was checking the JSON status here. You can see it was looking for, well, maybe it was a 402 error. And again, how this becomes misleading is HTTP also has response codes, right? Like we just saw the 200 for the HTTP response code, but so does MapQuest with this JSON. But as we know, HTTP doesn't go into the 600s, right? It stops at the 500s. So these are all values that are being checked for with response to the with respect to the MapQuest JSON response. And so that's what we were looking for. And you can actually see all of these, the JSON response codes. If I was to say MapQuest JSON response codes, I think that's going to pull it up. And MapQuest JSON response codes. I'm trying to avoid going to the developer. So it looks like I might have to go to the developer. So if you go to developer.mapquest.com, and it shows I'm still logged in. If we come to the documentation here, and we go to the directions API, and we go to the get for the route, I believe it was in here where they had the JSON status codes. I swear it was in here that I saw it. But this should give us a listing of all of the status codes that we could possibly run into with respect to the MapQuest API and its JSON response back to us. And again, I don't see them in here. I'm trying to remember where I saw them. But yeah, they're not in here. So, but those are JSON response codes. So now if we take a step back and we pop back over here, right, to what we had set up here, we were looking at a really simple example of not being able to concatenate a string and an integer. And so what we would have to do is we would fake out Python, right, and cast the integer for that statement as a string. That does not convert num1 into a string permanently. It does it just momentarily right here for our purposes. Because again, if I was to say type num1, it is still an integer, right? It's still an integer. So that doesn't actually convert permanently that value or this variable, which points to the value 99. It doesn't permanently convert it. It temporarily converts it so that we can concatenate it. Now, let's talk about the other approaches we could have used here. So I could have also said something like this. And this is kind of like my preferred approach because I really like the format method with strings. I could have said the value of num1 is, and then you see this as well in the MapQuest activity. And remember, the open brace, close brace, that's a placeholder. And sometimes you'll see a number in there like that. And what that means is it just means that when you get to the format method at the end here, that like, let's say you had 3 or 4 different variable values that we were going to be working with, you could number them 0, 1, 2, 3. But if they're already in order, there's no need to do that. And so now I say dot after the string, format, and then I put the value in here like that. And remember, right, this right here, this dot format, that is a method that's part of the string class. And what it does is it takes whatever value or values that you're providing in the parentheses here, because it's a method, and it just drops them in over here where you have your curly braces. So here we have, so let me give you some different examples, right? Let's build out here. So that works, right? And you can see I don't have to typecast it by doing the string function because we're not concatenating, right? When you concatenate, yeah, we got to flip it to a string because you can only concatenate a string to a string. But down here, I'm being a little more savvy. I'm just basically saying, well, I'm going to use the format method, and then I'll just put the name of the variable here, and then the value gets dumped in right there. And so it's almost as if the conversion of that integer right there auto-magically takes place, and it gets flipped into a string and dumped inside these curly braces. So now what if we have another number here? Let's say num2 is, I don't know, 88. For the crazy 88s from Kill Bill. All right, so it's num2 is going to be 88. So now if I wanted to say print, I could say the value of num1 is, and I just throw my curly braces in here, and the value of num2 is, and I'll throw some other curly braces in here, and that's the end of my string. And then I say dot format, and what do I put in here? I put in num1, comma, num2. I put in the 2 variable names that I want the values for. And the way that this is going to work is you're going to see right here. Oops, sorry, that's black. You're not going to see that. So let's change the color to red. So num1 is going to be the value that gets put in here because those curly braces are first. Out of all the curly braces in that string, those are first, and that's the first argument to this format method. And then num2, whatever the value of num2 is going to go in, is going to be replace those curly braces there. And that's how this would work. And again, this is how I kind of prefer to do. Sometimes I'll use F strings, which are different, but this format method is really nice. Let's hit enter. Now, let me recall that line. What if I do this? If I say num2 and num1, now when I run it, take a look at what happened. So num2 now no longer, it's here, it's the first argument, so it's going to be inside the first pair of curly braces here, right? So the order matters when you don't have the index position of the arguments in the curly braces. But what we did here, the very first one here, right? You can see that num1 is curly braces and the value of num2 is curly braces. And then num1 we put first and then num2 we put second. So there's no need for numbers. So what if I wanted to put the arguments in here as num2, num1, but I want to make sure that this still works? Well, here's what I'd have to do. I'd come here and say 1. And again, just like a list, Python is a zero-based counting programming language. So now the first curly brace is going to look at the second argument, index position 1. And the second curly brace is going to look at index position 0, which is num2. So now this will actually work and do what we want it to do. So that's another approach that you could take. Again, they show you this in some instances, but then they'll show you that concatenation. So again, just little semantics. So let's do a quick check here. Everybody comfortable with concatenation of the strings and what you have to do if you're trying to concatenate things and one of those things is an integer or some other data type, and how you can kind of work around that by using the format method that is built in to the string class. Is everybody comfortable with this? Does this make sense? All right, hold on. Somebody's putting something in the chat. Let me click on the chat. Okay, good. All right. Okay, excellent. All right, good. And that's what we want, right? Make sure you're tracking. And again, if you're not, just ask. It's not a problem, right? That's what these meetings are for, really, is for you guys to ask questions about the material. So if we're good there, right, let's take a step back over to our Dev ASC virtual machine located in Maryland. Let me shrink this a bit here because I'm not a fan of how everything, oh, there we go. Everything kind of wraps around all the time. So we left off taking a look at sort of our final setup here. And you'll notice that in our final production here, that for the trip, we had the duration, we had the miles and the kilometers. Remember that the fuel thing is not supported, right? Fuel thing is not supported. And so you can see here for the status codes, they've got you using the format method, which we just looked at, right? Where you've got the curly braces in here, and then you've got the dot format, and then and then the variable name that you want the value out of to print out right there. But right up here for the maneuvers, right, they're doing concatenation. They're concatenating and they're using the format method. So there's nothing that says that you can't combine those things. Again, Python is pretty flexible from that perspective. Okay, so let me clear the screen here and let's back out. And so now what we're going to talk about is something that's going to be coming up here very quickly. And this is called sample app, right? So you guys are going to be working on this when we get to module 6, but it's not too early to talk about this because it dovetails nicely off of what you just did. But we want to explain some of the things that you're going to see here. So we're going to look at this sample app, and the premise of this activity is, okay, well, I want to build an application that basically is running as part of a web framework, right? As a web server. And you can think if you're familiar with the Apache web server, right? But this is going to use a web framework called Flask. And you can see the name here, right? You can see we're importing, from Flask, we're importing the Flask class, and that's why it's got the capital F, right, at the beginning of the name. Remember, we talked about our class names. Best practice starts with a capital letter so that we can differentiate those from methods or functions or attributes. So, and then from Flask, we're going to import request. And you're going to see what request does here in a second. And then we're going to import this render template. And what render template is going to allow us to do is it's going to allow us to have a web page, right? With like an HTML page. And you can see right here, there is the name of the page. But we want to talk about what happens after we do this. From Flask, import Flask. From Flask, import request. From Flask, import render underscore template. So what we do here is we create an object, right? So you can think about this again. If you have a class like we do Flask, you could create objects from that class because classes are just object factories. They create objects. We tell them we tell them what we want the name of the object to be. In this case, it's just going to be called sample. And so we're going to generate an instance of the Flask class. And you can see in here, and this is where it gets a little bit tricky, we've got that dunder name, right? So underscore underscore name underscore underscore. Now, the value of that would depend on whether we're running the program directly. But when I say running it directly, what I mean is we type in right here from the CLI, and I'm going to actually, this is what I'm going to be doing. We're going to be typing in Python 3 sample underscore, and let me spell sample correctly, sample underscore app.py. That is considered to be running it directly. That is different from me importing this Python module here, this little script I've created. It's different if I imported it into another Python script. And that's not what we're doing. We're running it directly. So if I'm running it directly, the value of dunder name is going to be dunder main, right? And you'll see down here, and we're going to circle back to that in just a second, but you can see we're checking to see, hey, if dunder name is main, meaning I'm not importing this into some other Python program, I'm running it directly from the CLI, that is going to be true. Because dunder name, when you run it directly, will be dunder main, the string main. That's the name it would get. And so up here, we basically go ahead and create a Flask instance. And the value here is going to be the string dunder main. Now, this is where it gets really confused. Oops, sorry, I keep going over too far there. So this is where things get a little bit confusing. And this is kind of a little complex from a Python perspective, but I'm going to break it down. It's going to be super, super easy for you guys to understand. So what is happening with those 4 lines? Well, I've got 1 line commented out. So what is happening with those 3 lines of code that are not commented out? So the first line, let's tackle the first line here. All this is this is referred to as a Python decorator. And I want you to think of the decorator as the icing on top of the function cake. Because what's right below that decorator? We have def main. So we're creating a function right below the decorator that says at sample.route, and then we've got this / in here. Now remember, we just created a Flask, and you can think of it, let's just think of it as like a Flask web server, right? An object that's going to be some kind of a web server. And so what I'm saying here is this little decorator says, when someone accesses my sample web app and the route that they go to on that web app is the root of the web, which would be, and let me give you some examples, www.cisco.com, enter, right? That's going to take you to cisco.com to their index.html page, right? Their landing page, the top of their web directory. So all this is saying is when someone goes to what will ultimately be localhost colon 8080, that's the top of the web directory. Because again, I could have, after the / I could have like, you know, a some name.html, right? And then it would take you to a different page. But this decorator here says if someone goes to localhost colon 8080, which is the top of the web directory, the directory structure, I should be saying, then this function right here is going to render this index.html page. So it's going to show you an index.html page. And that's all that's happening in these 4 lines of code right here. Now, we've got this return render template. And so the render template says, yeah, you're going to see that on a web page, and the name of the web page is index.html. Now, you've got to create that index.html page. Or actually, I'm sorry, it'll render it for you as this index.html. If you didn't want to see a web page, if you wanted to use the curl command to see what was going on, we would uncomment out this line here, right? But that's all that this is doing, right? Now, these last 2 lines, which you see a lot, is basically saying, if you're running this program directly, then what am I going to do? Well, there is my Flask object with the name sample, right? I created that object from the Flask class factory, and we have a method here that says, okay, if the guy types in, or if the user types in Python 3 sample_app.py, then I'm going to run a little instance of a web server. And this statement here just says, bind it to all the interfaces on that system that are up, which means on the virtual machine, just bring it up on every interface that's up, and run it on port 8080. And then if I go to localhost colon 8080, it'll display the page. And let's see if that's what happens here. So I type in Python 3 sample app, and you can see it tells you right there, running on HTTP quad zeros 8080. So on the dev ASC virtual machine, if I pull up my Chromium web browser, and I didn't want that to happen there, it drags the zoom menu down, and I come right here to localhost colon 8080, and I'll click refresh, you can see that this is what we get. And I apologize. I think I commented it creates the index.html. It doesn't create it. It's in the templates directory, and I'll show you that here in a second. But you can see the code. This is the HTML code that if someone goes to my root directory in the web directory hierarchy here, the main landing page, this is what they're going to see. And it shows you that I'm coming from 127.0.0.1. So let's take a step back here, and I'll kill the process, just Control C, and take a look. There was when I refreshed it a couple times, and what do we get back? HTTP status code 200, meaning it worked. And so this is like a little log that the web server, the Flask web framework, keeps track of here while it's running, so that if you're testing and you want to see, hey, what's going on there, that it'll work. Now, 2 very important things here. The first is that Flask looks in the templates directory for all of your HTML files. And there is my index.html. So if I say more index.html, there you go. And that's all that you're seeing right there. And you can see here it says you're calling me from. Now, this representation right here, that curly brace, and then the request dot remote underscore ADDR, this is referred to as Jinja 2. And Jinja 2 allows you to work with Python and everything that the Python script is doing, and you can even use the variables out of those Python scripts so that you can dynamically display the information here in your index.html page, right? And so when we look back at, let me get out of this directory, sorry. And the CSS is in static. So there's these two directories that you would want to create. And again, if you're using CSS, which is just cascading style sheets, in order to, and I think I used it to change the background and hold on, I wanted static there. Static and style.css. And there it is. And all I did was for the body, I made the background the light steel blue, right? And that's all the CSS is doing. And so again, super, super simple example of how you can actually build an application. And what you'll be doing in chapter 6, in module 6, is you'll be building this web app right here. And what you're going to do is you're going to containerize using Docker. You can actually make a container that will run this app for you every time you run the container, right? So let me ask you this to make sure that we're tracking here from the Python perspective. If we look at sample_app.py, does everything I talked about there make sense in terms of what Flask is, what it does? It just runs like a little web server for you. And you can create web pages that it will render when someone goes to a certain area of your site. Does this make sense? Is everybody feeling good about this? And again, this little at thing right here, just think of that as the icing on top of the function cake. Okay, I know it's the first time you guys have seen it. So, and believe me, you'll see it again. And we're going to talk a little bit more about this in just a second. I'm going to show you some additional examples. But the decorator, again, the decorator goes hand in hand. It's inextricably linked to the function immediately below it. Because again, if I go to localhost :8080, right, that's considered to be the root of the web directory, the website directory, then this function runs, def main, and it renders the index.html, and it just creates the index.html page for you. And that's exactly what it does. All right, so let's do this. This is going to be a good breaking point here. Unless there's any other questions, we'll go ahead and break right here, and we'll break until 8:10 to do a little bio snack action, and then we will come back, and I'm going to show you some additional examples of Flask and how Flask is going to be used here in module number 6. So let me pause here. All right, so everybody's still with me? We've got everybody? We're not missing anybody? All right, so here's what we're going to do. We're going to take a little break. We haven't been able to do this the last week or so, but now we've got kind of a quorum here. So I'm going to go ahead and kick off we'll do the Gold Quest version. And this is going to be all about the REST API work that we did. And there's quite a few questions, so let's bump it. I'll keep it at 8. All right. Let me kill the sound there. All right, so everybody go ahead. There is the Blooket join code. So go ahead, let's get everybody in there real quick. So Dylan, Dwayne, Christy, Nathan, and Ryan, go ahead and dive on in. And this is going to be a good activity here because it's going to go over all of the module 4 stuff that we've talked about so far. So if you've dug into module 4, you should do extremely well here on this activity. And then we'll transition from here back to some Python stuff and some network programmability. All right, we got Dylan and Ryan, so we're just waiting on Nathan, Christy, and Dwayne. All right, there's Dwayne, so we're just waiting on Nathan and Christy. All right, we got Nathan. So Christy, we're just waiting on you. And then we will get going here. All right, we've got everybody. Let's go ahead and start. And Gold Quest is actually pretty cool because I think you can actually steal other people's gold. Yeah, there you go. Take gold from others. All right, most gold after 8 minutes wins. And here we go. So now we're checking your module 4 knowledge here. Want that? I don't know when that popped up. There we go. All right, Dwayne is in the lead with 50. All right, Ryan took 13 gold from Dwayne. And then Ryan jumped into first place. Yeah. Gold Quest. All right, Christy in first place with 100. But the stealing of gold will commence here shortly. And then people will start losing all kinds of gold. All right, Christy in first place, followed by Nathan, followed by Dwayne, and then Ryan. Dylan, I know you're about to get on the board any moment now. All right, Christy back to 90. And top of the leaderboard. All right, Dwayne now in the lead with 67. Ryan stole 7 gold from Christy. Ryan is like stealing from Dwayne and Christy. In fact, Ryan is the only one to have stolen any gold. Dylan, I know that any moment now you're going to be on the leaderboard here. And there's Dylan. All right, Dylan has awakened. He is in first place with 90, followed by Christy and then Dwayne. We've got 5 minutes to go. All right, Christy stole some gold from Dylan. Well done, Christy. All right, Christy jumps into first place with 180, followed by Dylan, Dwayne, Nathan, and Ryan. All right, Dwayne jumps into second place with 134. Dylan up into second place with 161. 4 minutes to go. All right, Dwayne has hopped into the lead with 180, followed by Dylan. Christy swapped gold with Dwayne. Whoa, Dwayne, I don't know what just happened there, but Dwayne jumped to 440 before Christy just took 110 from Dwayne. Christy's in second place, followed by Dylan, followed by Nathan, followed by Ryan.
Hey, Christy, you're on my team, remember?
Not when we're doing Book It. Christy and Ryan just looting and pillaging gold from people here. All right, so Dwayne still in first place with 330, Dylan at 291, Christy at 211, Nathan 60, Ryan 41. And Nathan pops into first place with 330. My guess is you may have switched with somebody, probably Dwayne, who now has 90. 2 minutes and 30 seconds to go. All right, Dylan up into first place with 351, Nathan at 330, Dwayne at 260, Christy down at 106, and Ryan at 41. And hold on, Christy just took 88 gold from Dylan. All right, Ryan up to 142. Christy climbing back up the leaderboard at 234. Holy Toledo. Dylan just took 83 gold from Nathan. Ryan up at 426 and in the lead. Dwayne at 300. All kinds of movement now. Minute and 30 seconds to go. Christy at 702. Ryan just stole 70 from Christy. All right, we're down to about 60 seconds to go. Christy in the lead at 632, Ryan with 526, Nathan at 247, Dylan at 205, and Dwayne at 175. 1 minute to go. Ryan in the lead at 641 because he took 65 gold from Christy and then 70 gold from Christy. We got a close one. 4 points separating first and second place. 30 seconds to go. 30 seconds left. All right, Christy in the lead. 15 seconds to go. It's Christy, Dwayne, Ryan. Wait, it's Dwayne, Ryan, Christy. Christy back into second. 5 seconds. 5 seconds to go. And here we go. Final standings. Christy in third. Dylan in second. Dwayne holds on. 708 gold in first. All right. Excellent job. Excellent job. All right. A little review there from module number 4. Okay. So what we're going to talk about now. Yeah. So on the gold quest, on that theme, people can steal money from you and you can lose money and stuff like that. So, all right. So let's go ahead and dive right back into our Dev ASC virtual machine. Let me get that out of the way there. All right. So we were talking about Flask, right? And what we would do to create a little Python application. So the first one we looked at was we wanted to render this HTML template. And so what I'm going to do now is I'm going to copy what we just did, which I think was, sample app. So let me come back over here and let's pull this back and we're going to say copy sample app.py to simple sample underscore app.py. And we're going to VI simple. Whoops, didn't want to do that. Hit enter too quickly. And so here's what we're going to do. we're going to clean this up a little bit, and let's remove some complexity, because there's another way that we could do things here. We don't have to display a web page, right? So there's really no requirement that says we have to display a web page. We can actually just start the web server up so that it runs on port 8080. And in order to access it, we can simply run a curl request. And the curl request is pretty simple. Remember, curl is just running a GET request for us. So if I was to say Python 3 and simple sample app.py, you can see that there it is. It's running on port 8080. So if I just pop over to a different window here, let's get that out of the way. If I say curl http colon slash, http colon slash slash localhost colon 8080, you can see that we get back a response. It says, you are calling me from the IP address 127.0.0.1. And that's what we saw on the web page. And Dwayne has a quick question. He said, I have a question about the code. If the status code was 0, could we have ended the program there because there were no errors? So Dwayne, you're talking about the map quest, correct? Are you asking about the map quest? Okay, yeah, let me transition back there. That's a good question. So let me do cd ... map quest, and there we go. So Dwayne's question is about the JSON response code. So if the status code is 0, we don't actually end the program there. And let me show you what I mean. Come down to the bottom here. So it's not really, well, I guess it's going to print out the last turn-by-turn directions here is what it's going to do, right? And then the program will end. So yes, if the JSON status is 0, it prints out all of the legs of your trip, the turn-by-turn directions with the narratives, and then that's it. That's the end of the program. And so if I was to run this, Python 3 and *7*, and we'll say South Lake Tahoe, California, and Crofton, Maryland. All right, so there we go. And so you can see it prints everything out. And it's not that the program quits. It's just that for that set of directions, you're done. And now remember, we have everything is inside of a while loop. So this is going to run until I type quit or queue, right? So I could type in something else. So how would I go from San Diego, California to Santa Rosa, California? Right? And then it's just going to continue to run. And so here's something that I want to get fixed, actually. So you can see what's happening here. Do you guys see this? Where everything I'm doing, this is supposed to be inside of parentheses, but the closing parent is missing. And I just kind of punted on this when I created it. So let's go in here and let's see, little troubleshooting. If it's printing turn-by-turn directions, and that, and that's what it's doing up. Well, no, it popped me out of the window there. And so right here, it's printing the turn-by-turn directions, right? The maneuver. So now the problem is it doesn't have the closing parenthesis for the distance, I think is the value that we're missing there, is the distance. And so as you can see down here, we've got teed up over here, and this is probably one of the more confusing lines, right? So we've got the print parenthesis for the print function, and it opens up there. And let me draw here for a second on this. We'll draw, and let's do yellow. So that parenthesis right there should be with this last parenthesis right here. And then the next parenthesis, which is the maneuver, right? You could say that this one is with that one. And then we've got this one here, which is actually part of the string. And so we're missing the other parent which, if I'm not mistaken, should go right there, right? And so I think that's why we're missing that parenthesis. So let's clear this. And again, when I did this and I teed it up, I didn't want to get bogged down in trying to figure out where it was at, but there it is right there. I think that's what we're missing. So let's rerun that. And not VI, where are we at? There we go. All right, so we'll say Santa Rosa, California, and we're going to go to Zephyr Cove, Nevada. All right, there we go. And it fixed it, right? So now we've got the closing parenthesis there on all of those values. So that was a mistake that was there. So Dwayne, does that answer your question? So the program doesn't actually quit or stop. It's just that that iteration of the program will be done if the JSON status is 0. And what we're checking for there, again, is to make sure that MapQuest is telling us that, hey, here's the JSON data and there were no issues. Because if I do the following, right? If I do the following and I run this program and I put nothing in for my starting location, and then I put in Crofton, Maryland, that's going to be a problem. And right there, you can see, oh, you know what, the response that we got back. So and it says the response code from your API was 611. And so that's the response code that we're getting back from MapQuest. That's not an HTTP response code. That's a MapQuest response code that's in the JSON data. Because what I can do is, again, remember, we're printing out the URI. So I can copy this. I can go over to Chromium. And I can go right up into the browser URL section here and paste in the directions from nowhere. I don't put anything in there, and I want to go to Crofton, and here's what's going to happen. And there you go. So MapQuest gives me a status code back that says, hey, you know, this is bad, right? 611 is bad. You can see up here for the route, the error code is a 211, but we were checking for the status code, because if it's not 0, anything other than 0 from MapQuest on the JSON response means that something went wrong. And I'm still kind of bummed out here. I swear, hold on one second here. MapQuest API response, whoops, response code 611. Here we go. Status codes, yes. MapQuest developer, and it is in the developer area. Here is what we're looking for. Okay, fantastic. I found it. Let me grab this. Whoops. Let me grab all of that. And I definitely want to make sure that you guys have this. So let me drop this into the chat. And so here, right there is the link to get to the MapQuest developer status codes. And I am going to drop that right in here so that I have it. And I'm actually going to drop that into my documentation so that I have a copy. So we can see it's a little bit larger here probably. So here are the general status codes, right? Hosted data status codes. So you can see the 611 hosted data general error. Right? And that's what we saw when we saw that 611. And then there's all kinds of other status codes that you can get back. And remember, the only status code that is a successful search call with the MapQuest API is 0. And keep in mind, right, these are not HTTP status codes. These are MapQuest status codes. Does that make sense? Does that clarify everything?
Yes.
All right, fantastic.
So when I was asking about like the like if it ended, I used to work with control systems, and we did line coding with kind of like a basic system. And we'd have, if a condition was met, we would end the program rather than going on to, other possibilities. If this was true, we'd end the program and then the program would restart. If we got to that line where the condition was false, we would keep going till it found what condition it met. So that's, and I know this is different. Python's different. I was just curious if there was anything like that, or so that it didn't have to keep going through the entire program. If it met its condition, it could stop and restart.
Yeah. So let me put this out to you guys. With our MapQuest application, what is the condition that would get checked that would end this from running? And it's actually on the screen there. Hopefully you can still see the screen. So what condition are we checking for? Yeah, Christy, outstanding. Yeah, Dylan, it is the user input, and Ryan, good. So the condition we're checking for is this condition right there. If the user enters Q, lowercase q, or types in quit like this, that's it. We're all done. And let's look at that code real briefly here. So we'll say more *77 or *7*. And so here is our condition, right? Remember, the user is going to get prompted for the origin and the destination. Now, if the origin, right, if whatever the user types in, so let's take a step back here. So origin is a variable, right? And we're using it to capture whatever the user inputs here. So the user's prompted, enter your starting location or quit or Q to quit. So if whatever value origin points to, right, or whatever value origin contains equals the string quit, or origin equals the string lowercase q, break. And the break takes us out, it breaks us out of the while loop, right? So think of, we're breaking out of the while loop. Well, this entire program is inside the while loop. So if we break outside the while loop, then that's it. It's game over. The program is done. And we have the same thing. We give the user the option, like, and again, I guess the use case here is maybe the user types in where they're starting from, the origin, and then realizes, I don't want to run this program anymore. So when they go to type the destination in, they can also type Q or quit, and they'll break out of the while loop. And again, the key here is it's all about the structure of our program. So if the entire program is inside this while loop, which it is in our case, and we say if the user types Q or quit, we're going to break out of that while loop, then that's it. You break out of the while loop, and if that's the whole program, then it stops and the program is over. And I think the logic that you kind of mentioned there, Dwayne, is we check for something, and if it's true, right, like they say they want to quit, then the program is over, and then we could just run it again or go off and you could do something else. So does that, let me first check, does my response, my answer kind of makes sense as to what the two conditions are that we're checking here to see if they're right? And that's a good question, by the way. Okay, good. So here's another way that we could do this. So let me give you an example of what I think would hopefully resonate as well. So what if we grab this code here and we could do something in maybe a little bit larger of a scale? So I'm going to step over here, and what were we doing here? I'm not sure what's going on in this window. We'll jump out of that window here. Okay, so if I had like a simple Python program called demo.py, and in this program, I'm going to say, we didn't want to break in there. So I'll say while true, we're going to, so again, it's kind of the same thing. So we'll say while true, and then I indent, right? And we'll capture, we'll say user input. Oops, sorry. User input is going to be input, whatever the user types in. Type in something or Q. Wait, we don't do that. Or Q to quit. So we're going to do something simple here. And so then it's here. I would say if user input is equal to Q, break. Now, the entire program is not inside the same while loop. So I could have something down here that would say, okay, while this is true, right? So we would run this, Dwayne, until the user says Q to quit. And when they do, we move on to the next task, which would be, and let me grab this here to save some time. We'll say copy, and then we'll dump that in there to paste it in. And we got to insert some things here. There we go. And so then it would run this one here. And maybe we put a print statement in here for, it says print, you are still in loop 2. All right, so what this is going to do is when we start this program, it's going to run, it's going to do this right here until I say Q. It's just going to have me type something in until I say Q. And as soon as I say Q, that's it. This little portion of the program is done. But then what do we do after that? Then this starts to run. And so you can have multiple while loops in the same program. All right, well, let's see what happens when we run this. So we'll say Python 3 demo.py. So you can see type something or Q to quit. So I type something in. And it's just, you see that? So yeah, I'm typing it. And then when's our condition going to be met? I can even just hit enter. It's just, and I'm still in that same loop. But now I'm going to say Q and hit enter. So we break out of the first loop, and now I'm in the next while loop. So then this program, or this part of the program, is going to run and run and run and run and run until I enter Q. And now the entire program is over. And so that might be, Dwayne, is that kind of similar to, you're doing the line code, it's running, you're typing something in, and then conditions met, and then it's over with. And then you just move on to the next condition, right? Okay, good. Yeah, and then you just kind of move on to the next condition, and that runs until the condition is met, which is we type in Q to quit. All right. Whoops. All right, so let's jump back over to our Dev ASC virtual machine located in Maryland. And so we'll come in here and we'll go to, what was it, sample app. There we go. All right, so in here, we have a Python script, right, called simple sampleapp.py, which it was just a copy of sample_app.py that we went ahead and modified, and we took out the render template. And so now when we run this, it's just simply going to be, we would run a curl command. Now, here's what's important, right? Let's start this up again. Let me say Python 3, and let me say simple sample app. Now, again, Flask is just a web framework that is inextricably linked with Python and works exceptionally well. But it's, again, you can see that you're going to get a note here. It says, do not use this in a production deployment, because you would not use this. You would use probably Nginx or Apache. And so you can see that it says it's running on port 8080. So let's confirm that. Let's come back over here. And let me run that curl command again. And there you go. Now, let me ask you this. When I pull the web page up here, and I go to sample app, and I click refresh, right? You can see that we're not rendering the web page with the render template, but it still says you're calling me from IP address 127. And there's no, you can see the style.css is not in here. It doesn't say woot woot or anything like that. It literally just shows you that right there. So it's still going to show you something, right? It's just not, oops, sorry, I didn't want to do that. It's just not going to show you all of the HTML code that we had created or the style.css that we were using, right? And so that's kind of the basics of what you're going to do there. So let's take a look at something else that you're going to see when you go to work on things in module 6 for the sample app. And it's going to be good to hear this more than one time. And how did I get into the REST-conf directory here? Oh, that was in a different window. All right. So here we are. So let's take a look at this bash shell script here called sample-app.sh. All right. So there's a lot of moving parts here, right? So our login shell on the Ubuntu Dev ASC virtual machine is the Born Again shell, or bash, B-A-S-H, stands for Born Again shell. And on the CLI, we can make directories, right? We can copy files. We can type in echo commands and redirect that output. And if you've got a bunch of that stuff that you're going to do over and over and over again, what you could do is you could take those commands that you would run on the CLI, especially when it's like a lot of commands like this, right? These are all commands, right? And again, you guys know the make dir command. This is how you make directories. You guys know the copy command, and the -r just means recursive. So copy the templates directory and everything underneath the templates directory, and that's what the -r stands for. And we've seen the echo command before, where you just type in echo and then it echoes out some string that you want it to echo out. And that's what we're doing here. And we put it inside of a file and we give it the name sample-app.sh because we want to run this and have the file, right, the bash shell script, run all of these commands for us all at one time, right? All at one time. And that's the idea behind a bash script. So what is this doing? Well, the first thing it's going to do is it's going to make a directory called tempdir, and it's going to do it in the directory where the sample-app.sh file resides. So it's in this directory where it's going to do these things. It's going to make a directory called tempdir, and then it's going to make a directory inside of the tempdir directory called templates. And remember, the reason I mentioned showed you the render template is because it's in the templates directory that Flask will look by default for your HTML files, and specifically here, the index.html file. And that's what we're going to create. And then it's going to create another directory in tempdir called static, because it's in that directory that you would have your style.css file. So it makes these three directories, tempdir, and then inside tempdir, it makes templates and static. Now, then we've got our three copy commands here, which are actually pretty simple. So we're going to copy the sample_app.py. That is the Python app file that we just looked at that had the Flask definition. I had the Flask object being created, and then we run that. And we're going to copy that into tempdir. Now, the dot at the end of the line here is always a question that comes up. Well, doesn't that mean the current working directory? Well, when we're running a script, right, a bash shell script, when we go to copy something and we want it to go into that directory, the script is running in this directory. So we just put a period at the end to say, put it in tempdir, and then the dot is inside of tempdir with the same name. So you're going to end up with a copy of sample_app.py in the tempdir directory. And then we do the 2 recursive copies. So we're going to get everything out of templates that we have in this directory and everything out of static, and we're going to put it into the temp dir, right? And that's all that those lines are doing. So you might be asking, well, wait a second, what is in templates? Well, if we go into templates here, you can see you've got the index.html file. And this is, again, what you saw before, where it just simply has in here, you're calling me from, and then it uses the Jinja 2 data mod or web framework here, and it shows request.remote_address. Now, remember, this is not HTML. What's inside these, and in neither the curly braces. So this is considered to be Jinja 2. And they don't talk about that, but it's good to know that that's what that is, because this is what's generating that value of where you're coming from, right? So request.remote_address. Well, what is that? Well, remember back when we looked at sample_app.py, whoops, sorry. Oh, and I'm in the templates directory, so hold on one second. So remember, what do we have? We imported this module here, right? So we imported the request module. Well, that code right here, this Jinja 2 code, basically works hand in hand seamlessly with our Python application file. And it says, oh, okay, well, the Python script imported request, so I can use request dot and then get the remote address. And that's all that's taking place here. Again, remember when we said you're calling me from the IP address, that is how you got the remote address. And so using Jinja in the HTML file will give you that same value. And that's how you would format it here, right? Is just the curly brace, request.remote address, very similar to what we did in the Python file, right? And then you just capture it inside the double curly braces. And so that is what the index.html is doing. And the the style.css, which is here in the static directory, again, that was very simple to show you that again. That just turns the background light blue. And so those files are being copied. Whoops, let me go back up one here. Let's clear a new ls. Those files are being copied by, and I can cap that out, I guess, since it's not too long. Sample-sh, there we go. They're simply being copied into this temporary directory. So we're copying all of our stuff, the index.html, the style.css, and the Python module that we've created that runs a Flask web app. We've copied all 3 of those files into these different directories in the tempdir directory. So then what do? So these are going to create what's referred to as a Docker file. And so Docker allows us to create a container. And you might be asking, what is a container? What is a container? So at a high level, a container is, think of it as a self-sustaining or self-sustainable, independent, mutually exclusive, hermetically sealed little bubble, right? So when you create a container, the container typically does one or more things, and that is all that the container will do. And so the container that we're going to create, you can see we have these echo commands here. We're going to create a Docker file that will build a Docker container that is our web app. So everything you've seen me doing here, when we start the web app up here locally, right? When I type in, let me do Control-C. So when I sit here and I type in Python 3 simple-sample_app.py, and so then now I'm running my virtual machine, I'm sorry, my Python Flask web app here, and I'm doing it on my Dev ASC virtual machine. So think about it like this. If I said, well, I want you to create this app for me. And you're like, okay, well, am I going to build an entire Ubuntu virtual machine? Because the Ubuntu virtual machine image can be anywhere from 400 megabytes to, gigabytes in size. And that's massive, right? But what if I just want the app to do one small thing, which is return the address of where the user's coming from? And this is where containers are a super trimmed down version. It's even smaller than a virtual machine, because you might be thinking, okay, well, if I had to build a whole server just to do this, what a waste that would be, right? If it was a physical server, because you'd have to buy the physical server, you'd have to put the software on there, and then you're running it all on that physical server. If that's the only thing the physical server's doing, what a waste that would be, right? So then you might think, okay, well, Travis wants to run this web app. Well, let's do it inside of let's create a virtual machine. Well, remember, if you go to create a virtual machine, as you've seen with the Dev ASC VM, and as you're going to see here soon when we get into module 7, and you're going to build out a Cisco CSR virtual router, the images are quite large. They're 400 plus megabytes in size. I mean, again, that's massive. So to build a virtual machine just to run this little tiny web app, that Python app, that makes no sense at all. And so this is kind of the trajectory or the path that things have taken over the years, which is back in the 90s, everything was a physical server. And then VMware hit the scene, and then everything became a virtual machine. And then everyone was like, well, wait a minute, what if I just want my virtual machine doing like one or two things? And then we ended up at containers, right? And so Docker is totally free. You can download Docker for free. And in fact, you will. You download Docker for free, download it for free, and you can create just a little container. And the container is an optimized, again, like think of it as an optimized little bubble in which only the code that you want to have running and the other components that code needs are inside that container. That's it. Mega lightweight, right? Super lightweight. And then you can take that container and you can just run the container when you want your app to be run. And so it's much easier to do that from a resources perspective than a physical server or a virtual machine, yet you still end up with the application doing exactly what it was you wanted the application to do. It just does it in a highly optimized way by not consuming tons of resources. And then to build from there, you would say, okay, well, now that I've got my little container that runs this Python app that tells users where they're coming from, you could then run that in a Kubernetes cluster, for example, where your container would spin up and could survive on, different nodes inside the cluster and things like that. And the chapter will mention Kubernetes. You'll get Kubernetes, I think, is mentioned twice in the book, in the online text. But that's what you can do, right? Those are the things that you can do. And so that's why containers are a thing, is because I don't want to build a VM because it's totally way too much. In a physical server nowadays, it's like everything's virtualized, really. I mean, ultimately, you've got servers sitting behind a lot of stuff. But if you're going to run that web app and I told you, yeah, go out and buy a server to do this, you'd be like, that's nuts. That makes no sense. So that's why we containerize things. And that's exactly what this is doing. It's creating a Docker file, because the Docker file will grab Python. So let's run this, and here's how we'll close out. I'm going to show you an example here. So I'm going to go ahead and say, and I think actually bin bash is up there. So I'll just say /sample-app.sh. and I hit enter. And you see how quickly I get the prompt back? It just did all of this literally in the blink of an eye. Because if I say ls, hey, guess what? There's tempdir. That wasn't there before. Well, let's cd into tempdir and see what's in here. Well, lo and behold, there's the Docker file into which I was redirecting standard out. And the first one, I overwrote Docker file if it existed, but then I appended all of these things here. And that created the Docker file from which I can actually build my Docker container. And there's the sample app.py, there's the static directory and the templates directory. And so my Docker file knows that, yeah, we're going to grab everything out of static. We're going to put it in home my app. We're going to grab everything out of templates, do the same thing. And we're going to expose the service on port 8080. And then we're going to run Python 3 sample app. And that's what's going to end up happening. And so what I could say would be, in fact, I think I've got it teed up in here. Let me check real quick. History, grab Docker. All right, so I think it's Docker build, and I think it's -T, and I'm probably going to forget some options here. It's not T. I'm trying to remember. I can't remember off the top of my head the Docker command. There's a Docker build. Yeah, so here we go. So just Docker build dot, and you can see that using the commands that were in this Docker file here, right? And that's what we echoed into that file. It just built for me a Docker container. How do I see that? Well, I could say Docker images, right? And here are some of the images I have, and I got some other stuff I was building, but you can see 23 seconds ago, we built none, and we've got sample app, and I should probably blitz some of these, but you can see the sizes that these are once they get built, because they've got to pull down different images, right? So, and I'm wondering, oh, we didn't do it off the name, so I have to do it off the ID. So let me see, Docker RM, oops, sorry, not soccer. So Docker RM, and then we can grab this one here, and let's see if we can, all right, well, we're time, so I won't belay this, but I had a bunch of stuff I've been running in and out of. So, but that's how you build a Docker container. And if that container is running, then we can go ahead and use the service that container offers, which is our Python web app. And so that's a good stopping point for tonight. So as a reminder, there is no class, no meetup next week. You guys only have the Module 4 chapter exam due this coming Monday, the 20th. And you now have until Monday, the 27th, to get the team project together, which is 494. All right. So any questions or anything you guys have before we bust out of here for spring break?
I have a question.
Yes.
So when I was reading through in our textbook or whatever, when I was reading through the project, it was saying something about the presentation. So how are we doing the presentation if we're meeting after the project is due? How do you want that delivered to you?
Yeah, so the presentation is going to take place at our next meetup.
Okay.
Which would be the 28th, if I'm not mistaken. Is that correct?
Yes.
Yes. So on Tuesday, the 28th, we'll go ahead, and whoever the Scrum leader is, you guys will demo. I'll give you control of the screen. You'll share your screen. And then the Scrum leader for each team will demo what you guys came up with, and be prepared to talk about who did what.
Okay.
Who worked, like Christy did this, Dwayne did this, Ryan did this, Anj did this. And so just be prepared to talk about who did what, or maybe have the comments in your code that talk about that as well. And then you're going to run your code.
Okay. And all of the questions that were in the project, are we just answering what's on the PDF or going through all
Yes.
the questions? Okay,
No,
because
no,
there
no.
was like a
Only
bunch of
what's on the
questions.
PDF. Yeah.
Okay,
Great question, Christy. Yeah, only what's on the PDF, because that would be what gets turned in by the Scrum leader. And again, only the Scrum leader needs to turn in the PDF, and everybody on the team gets credit,
okay,
because it's assumed that everybody on the team is helping answer those questions.
okay. Okay, I'm good.
Okay, excellent.
Okay,
All
good.
right.
Thank
Well,
you.
again, guys, I'm in WebEx Teams, and even it's spring break, whatever. If you guys have a question, hit me in WebEx Teams, hit me over email, because I'm online 24/7. I don't care if it's spring break or not. I will be more than happy to assist. So feel free to reach out, even though we're not meeting next week. I'm still going to be online and available. So, all right. Well, you guys have a great spring break.